Linear data structure, linked list, link storage representation. There are many applications where sequential allocation method is unacceptable because of following characteristics: unpredictable storage requirement, extensive manipulation of storage data. One method of obtaining the address of node is to store address in computer's main memory. We refer this addressing method as pointer of link addressing. A simple way to represent a linear list is to extend each node to contain a link or pointer to the next node. This representation is called one-way chain or singly linked list, singly linked linear list. Here we have structure of, or you can say graphical representation of linked list, in which A is a node, in which A is information, and second part which contain address of the next address, and 5000 is address of the first node. Here we have second node, that is B. Address of that node is 1000. B is information, and remaining blank part that is useful for store the address of the another node. C is third node. Address of that node is 2050. Blank part that is useful for store address of the next node. D is fourth node. 3335 is address of the D node. Here we have generating link A, information 1000, that is the address of the second node, and we are generating this way link between A and B. Now generating link between B and C, 2050, that is the address of the third node. 335, that is linking between C and D, address of the fourth node. And last node, that is called null address, last value of address that is null, so that is called last node. Here we have simple singly linked list, singly linear linked list, in which we have four nodes A, B, C and D. And first node A is information, 5000 is address, 1000 that is address of next node. And second node B, address of B node is 1000, 2050, that is the address of the second node, third node. C, that is third node, 2050, that is the address of the C node. 3335, that is the address of the next node. D, that is the last node, address of that node is 3335, and last node is not linking any other node. So address part that contain null value, that is called last node. It is a linked list. A linked list allocation method of storage can result in both efficient use of computer storage and computer time. A linked list is a non-sequential collection of data items. Each node is divided into two parts. The first part represents the information of the element, and the second part contains the address of the next node. It is a simple graphical view of linked list. The last node of the list does not have successor node, so null value storage as the address. A and D, in which A is a node, B is a successor node of A. Here B is a node and C is a successor of the B node, and D, that is a successor node, and D have no successor node, so it is storing address as a null. It is possible for a list to have no nodes at all. Such a list called empty list. It is also one possibility of node. Pros and cons of linked list. Insert operation. First of all, we are going to discuss insertion operation. We have an element in list, and it is required to insert a new element between the first node and the second element. What to do with sequential allocation and linked list allocation? Insertion operation is more efficient in linked list allocation. Here we have node A, B, C and D. We are going to insert new node between A and B. So A address, A information, and 1000 is address of second node. Now we are going to change in address of A node, link address of A node, and we are going to insert new node. We are going to insert X node. So address of X node, that is stored at address portion of A node, that is 2100. Now A is going to link to X, and X, that is going to link to B. So X is storing 2050 address. Address equal to address of B node, that is 1000. X is storing to store 1000. So it is going to generate one link, and insertion operation is performed over here. We are inserting X value between A and B. Now deletion operation. Deletion operation is more efficient. We are going to delete P element from linked list. We have here 4 nodes A, B, C, D. We are going to delete P element from linked list. So we need to change address of second part of A node, that is address. We are going to remove second node, so 1000, that is storing address, that is address of B node. So we must remove that address from A, and we need to add address of C, that is 2050. So one node is removed from linked list. A is directly linking to the C. So A contain 2050 address, that is replaced by, that is previous address was 1000, it is replaced by 2050, that is the address of C node. So this way B node is removed from linked list, and this is called deletion operation in linked list. Now sort operation. If particular node is in the list is required, it is necessary to follow the link from the first node onwards until the desired node is found. It is in this situation it is more time consuming to go through linked list than a sequential list. Sort operation is more time consuming in linked list. Join operation, we can join one or more linked list. Join operation is more efficient in linked list allocation. We have linked list A, B, C, and D. Second linked list that contain address at information 12, 52, 15, and 1000. So we are going to join D with 12, D node with 12 nodes. So first remove null value from D node, and that is going to store address of the node number 12. That address equal to 5050. So here we are storing address of 5050 into D node, and we are going to join D link with 12. That is called join operation of two linked lists. Split operation, we can distribute or splitting up in linked list. Split operation is more efficient. We have linked list A, B, C, D. A, we are going to splitting from B from the center, so we must convert B into null value, second information B information, and address part must be converted into null value. So we are splitting here 1 from 2. Now first linked list, that is AB, second linked list, that is CD. Linked list required more memory compared to array because along with value is stored pointer to the next node, so it required more memory. Linked lists are among the simplest, most common data structure. They can be used to implement the data structure like stack, queue, and symbolic expression, etc. Operation on linked list, we can perform insert operation, insert at first position, insert at last position, insert into ordered list. These all are insert operation which are going to perform over linked list. Delete operation, traverse list, print list. We can delete from any place. Traverse list, we can traverse from first to last, last to first. Next, copy linked list, type of linked list, singly linked list, then circular linked list, Then doubly linked list. Here we are going to learn first singly linked list. As we simple learn in linked list. Here we have 4 nodes A, B, C and D, in which A it is divided into 2 parts. First one A is called information part, and next that is address of the next node. B, that is B is the information, and next that is address of the next node. A is the first pointer that is indicating first node. C, that is third node, next that is going to printing storing address of the next node. D, that is last node, address part of that node is null. It is basic type of linked list. Each node contains data and pointer to the next node. Last node's pointer is null. First node address is available with pointer variable first. Here we have pointer variable first, that is indicating first node address is available with pointer variable first. Limitation of single linked list: we can traverse only in one direction, that is forward direction. That is limitation of single linked list. We cannot traverse from any place. If you want to traverse, then we must traverse from beginning, it means from first direction. Node structure of single linked list: typical node, info and link. Info, that is data, pointer node to the next node, it is called node. Whole part is called node. Accessing part of the node: info, that is node. Link, that is part of node. Entity structure representative of node. Struct node: opening curly brace, closing curly brace, parenthesis, semicolon. Integer info, that is data. Struct node pointer link, that is linking to the next pointer, next node. Struct node star link, this way we can declare node into C coding. Information, or you can say integer data, that is data part, and link, that is struct node pointer link. Algorithm which are applying our linked list: insert at the first position, insert at the last position, insert order linked list, delete element, copy linked list, etc.